Alright, to basically get to the gist of it, I'm trying to learn Java. I'm switching over from JavaScript. And I basically built a Hangman game using command line interface to get more used to using Java. So I'll do a quick little breakdown of the files. I have the main and then a phrase class. So I'll go ahead and open main first. We're gonna import the scanner, but it's pretty straightforward. We just create a new instance of the scanner, and then we have a loop. And basically, until it gets broke, it's gonna open up a new instance of phrase, the phrase class, which we made ourselves, and it's gonna launch the game and put the scanner inside of it. So right before I finished, I was having a problem where after the second iteration, it would automatically end the game. And I learned it's because the way that I was using scanner needs to be passed into the phrase, because it was like the way that it closed out of scanner, it just didn't work right. Anyways, so then we're going to do the launch method of scanner. So we'll go ahead, we'll move over to phrase. The phrase class imports random and scanner. So I have an array of all the possible phrases along with their coded. I could also probably do a for statement that will create an array of strings in the same length, and as long iterates through it, and as long as it is not a space or a special character that I've used in some of these other ones, it could automatically make that, but I just hard coded it in. We have an integer chances, which every time chance decreases, it's because you got an answer wrong. The main variables they're all strings, besides the arrays of strings, and it's phrase, coded phrase, and split coded. Now we start getting into the methods of the class. We have a splitter, which basically takes phrase and coded phrase from the possible phrases, and it will split it so we can more easily manipulate and search it. We have a searcher method. Inside it's going to have a checker to see if you got any of the possible, like if the letter that you chose ended up being in the phrase, it will change this false to true. Otherwise, down here, if checker remains false by the end, it's going to decrement your chances. But anyways, inside this for loop, we're going to iterate through split phrase. And it's going to make sure it uses the lowercase values because, you know, we don't want to make people guess capital letters. It's kind of ridiculous. So it automatically compare it based on the lowercase letters. And so originally I wanted to run the code kind of like with JavaScript. I thought maybe I could do like string join and then this coded phrase, but it did not work that way. There's no join method like that, so I had to use a string builder, which was something new to me. I didn't know that existed before I did this project, so it's pretty useful. And I went ahead and I used the spring builder to make a new instance of it. Changes the checker to true. So the split coded, the index, so the individual letter within the coded array is gonna equal the same instance from the array with the regular phrase in. So basically, it'll put the capital or the lowercase, depending on the situation, because it doesn't matter. That never changed in split phrase or split coded. But it goes ahead and it puts the split phrase into the split coded. So as you're playing, the answers you've gotten right will show up in your coded phrase. And then this right here, it's a for each, which also looks different in JavaScript. And we're going to go ahead and just append the coded, and then at the very end we're string builder to string, this equals coded phrase. So we build a new string, which is what string builder does, and we assign that value to coded phrase. So then your results show up. We have a printer, and that basically just prints out how far you are. So it's a switch case statement. We use count, which we're getting from this dot chances. It's put in the code. I probably could have hard coded it here. Maybe, I'm not sure. Anyways, it doesn't matter. So whenever the printer method is called, it checks to see this dot chances, which has to be put in here. And it will see if it equals 6. If it equals 6, it goes to that 5, 4, 3, 2, 1. And then it, shows the appropriate string for how far you have not made it. And then we put it all together with the launch method, which takes scanner, as I was talking about a little bit earlier. It takes scanner. It initiates a random string. Let me rephrase that. It obtains a random string and populates the split strings. So we're gonna go ahead. We're gonna get a random number. Obviously, it isn't like 1, 2, 3, 4, 5. So we gotta do some altercations to it. So we're gonna make a new variable, an integer. Phrase index equals random. Next integer. Possible phrases length. There you go. You're gonna go ahead. You're gonna get a random integer from 0 to 9. But if we go back to our hard-coded phrases up here, obviously we only want to isolate one or the other. I think I went ahead and I went with the odd ones. So if it is odd, it needs to subtract 1 to get to the appropriate uncoded phrase. So we see that expressed back down here with that module right here. So make sure it's an unhidden phrase. And then we also will go ahead and put the coded phrase. This coded phrase. I'm going to go ahead and I'm going to move this line in here because it better fits my description with the comments. Alright, well anyways, now the game actually begins. We have another while statement, which encapsulates the whole thing. Well, almost the whole thing. It ends right here. And it's going to keep going until it is broken. So, it's going to print out the gallows. It's going to tell you to choose a letter. It's going to wait for you to put it in a line. It's going to check that length. It's going to save that in user length. And if user length equals 1, then we're going to search for user input within our string using the method we have already discussed. Otherwise, we're going to enter a while loop, and we're going to force the user to only select one character. Voila, because it doesn't equal 1, and it's going to keep doing this as long as it does not equal 1. It's going to tell you to choose only one letter. It's going to read up the next line, and then it's going to assign user length to length, and then check it again. Once you put in the appropriate length, it's going to search for that character. Well, I guess a string, but that letter, I should say. Don't want to get my new Java terms mixed up. So this dot searcher, we're going to search again for user input. And then it'll keep doing that until this dot phrase equals this coded. So basically, it's going to keep doing that until you have uncovered all the underscored tiles. So when all underscored tiles turn into the letters, it means you've unlocked everything. So it's going to end the game. Break. Or if you have 0 chances left, it's going to print out your gallows. It's going to print out what your phrase ended off on, and it's going to break. Why is this necessary? Why isn't this in the switch statement, you might ask? Because the print happens in the beginning. So if we scroll up here, this dot chances. So it prints in the very beginning. So if the game ends because you ran out of chances, it'll never print. So that's why it's important that we manually printed it right here. And then it's going to break. And then finally, it's going to see if you want to play again. So if your chances are greater than 0, you're going to get a congratulation message. You know, you did it. I just want to, I'm just going to do this because it looks more symmetrical to the other code. It doesn't really matter, it's going to perform the same, but I like it nested here instead of up there. So it's going to go ahead, print out whatever you had left, and it's going to say the sun sets heavy on this western town because you didn't save his life, he got hung. And then we're going to go back to main because we just ended the phrase launcher, and it's going to ask you if you want to play again, and you're either going to put in yes or no. And if again does not equal Y, we're going to say thanks for playing, and we're going to break. If we do enter Y, it's going to go ahead, it's going to go back to the top, it's going to make a new it's going to make a new object for phrase, so it won't matter what our last results were, it's all going to get reset. We're going to go ahead and we're going to launch the game, and we're going to put scanner back in, and it's going to loop, and it's going to loop, and it's going to loop until you say anything besides Y. So you could do N, you could do no, you could do yes, and it'll cut it as long as it isn't that lowercase y. And that's the end. So I guess I should probably show you a little demonstration. Alright. A, got an A. E, got quite a few E's. I, an I. O. Okay, there it is. U. See, there we go. There's my first one wrong. Got my head. So I'm going to choose another letter. Oh, look, I accidentally put BC. It's going to tell me to do another letter. I'm really bad at instructions, so. Look, I even put an empty string, and it got mad at that, too. So let's try again. Only choose one letter. S. Choose another letter. D. P. L. Oh, I won. Do I want to play again? Yes. Oh, no. Turns out I never really liked him, so I'm not going to save his life. What are my crimes? Ah! Do you want to play again? No. There you go. That's the app.